So I need your response for the problems that what you are solving. Okay. Yesterday we have started with first come first serve scheduling. I'm audible, right? Anyone else?
Yes, sir.
Are you listening? I couldn't able to see the chat box once I have shared. No response. Right. So listen, first in CPU scheduling, first method is first come first serve scheduling. So you have three different process, P1, P2 and P3. So you have a burst time of 24, 30, 3 and then 3. So this is the burst time of the process, each process P1, P2 and P3. Now once the process and its burst time are given, now what you need to do is you have to draw the Gantt chart. So this chart you need to do. So here this is the ready queue. This is the ready queue. The process are waiting in a ready queue along with its burst time. So now the process which comes first come first. The process P1 comes first. So immediately you need to allocate this to the CPU. You need to allocate this to the CPU. So P1 is allocated to the CPU. So P1 is coming. It comes under 0th second. So you are allocated CPU utilized until 24 seconds or 24 milliseconds. After P1 process, P2 is coming. You are allocating P2 in the Gantt chart, and so 24 plus 3 is 27. So at 7th second only it came, but because of process P1 is running in the CPU, so P2 need to wait until the CPU is free. So CPU is free at 24th second because P1 completes its work by 24. So P2 is entering at 24. It's executing for 3 seconds. So 24 plus 3, 27. Now P3 is there. P3 need to wait because P1 is running, P2 is run. P1 is already completed, P2 is completed. So then after P2 only it can able to run because it came at 3rd. So it is also having the 3 burst time. So it starts running time is 23 plus 3, 30. So total turnaround time, total turnaround time is 30. So at 30th second, all the process it completes its work. Okay. First, what you need to calculate is you need to calculate the waiting time for each process. Then you have to calculate the average waiting time for each process. So first we are finding waiting time. How to find a waiting time is how many seconds P1 is waited for execution. P1 it came first, it executed immediately. So P1's waiting time is 0. P2's waiting time is 24 because it got the CPU by 24 seconds. P2 waiting time is 24. Then P3's waiting time is 27. It waited until 27 to execute the CPU. So P3 waiting time is 27. Now you want to calculate the average. So there are totally 3 processes. So 0 plus this 24 plus this 27 divided by 3. So you got 17. 17 is the average waiting time of a process to get executed in CPU when compared to all the things. Next, you need to calculate the turnaround time. You need to calculate the turnaround time. So turnaround time, how to calculate? This is double T. Turnaround time, how you are going to calculate is what is the completion time of P1, what is the completion time of P2, what is the completion time of P3. So these 3 you need to find and divided by 3. So P1 completed time is 24. P1 completed time is 24. This is turnaround time is when it completed. P2's completed time is 27. P3 completed is 30. So you are going to add and divide by 3. So that you will results 1, carry over 1, 5, 6, 7, 8. So 81. So 81 divided by 3. So 81 divided by 3. So the result is called average turnaround time. So turnaround time for P1 is 24. Turnaround time for P2 is 27. Turnaround time for P3 is 30. Total, you don't need to total here. But when you're finding average turnaround time, that is A, T, T. If you want to find average turnaround time, you need to total like this: 24 plus 27 plus 30 divided by 3, 81 divided by 3. You will be getting the result. This is called average turnaround time. So 5 things you are going to determine or you are going to find. One is waiting time for individual process, average waiting time. Then you are going to find turnaround time, average turnaround time, and total turnaround time. 5 parameters you are going to find for each problem. Okay. Next, the same scheduling problem, but the process is running in a different order. Same problem, process is running in a different order. Now it means that first come first serve is, now P2 has come first, P3 and then P1. Now the P1's burst time is 3 and P3's burst time is also 3 and this is 24. The same problem, P1, P2, P3, same problem, but the order of visiting, the order of arrival is different. So the order of arrival is P2 first, P3 second, and P1 first. So now what you are going to do is, you need to execute, you need to allocate the CPU for the first process which came first. So you are allocating P2. P2's waiting time is 0. Its burst time is 3. 0 plus 3, 3. Next process is P3. P3 you need to add. So P3 is waiting until 3rd second because P2 is executing in the process. So P2 waited until 3 seconds. Then you allocated the 3 plus 3, 6. Then next process P1. So P1 is it will wait until 6 because P1 and P2 came before it is executing. After only P1 is coming. So P1 6 plus 24 seconds it is running in a CPU. 6 plus 24 is equal to 30. Now for this also you need to identify the waiting time and turnaround time. Waiting time for P1. So waiting time for P2 is 0. Waiting time for P2 is 0. Waiting time for P3 is 3. And waiting time for P1 is 6. So 6 plus 0 plus 3 plus 3 divided by 3. The average waiting time is 3. So if the process runs in a different order, the average waiting time will get reduced. Then you need to find the turnaround time. So turnaround time, the P1's turnaround time is, in any order you can take, P1's turnaround time is 30. So this is P1's turnaround time plus, okay, or individually you can write P1's turnaround time is 30. P2's turnaround time is 3. So P1's turnaround time is 30. P2's turnaround time is 3. P2's turnaround time is 3. P3's turnaround time is 6. So P1's 30, P2, when it's completed, P1 completed at 30 seconds, P2 completed at 3 seconds, P3 completed at 6 seconds. Now you need to find, we have find out turnaround time. Okay, so you find a turnaround time, TT. Now you want to find average turnaround time, ATT. So what you need to do, 30 plus 3 plus 6 divided by 3. So totally there are 3 processes. So 30 turnaround time, 3 plus 6. So 39 divided by 3. So 39 divided by 3. You will get 13, I think so. So 13 will be the average turnaround time. So 1, this is 1 you need to identify. This is the second one you need to identify. This is the turnaround time. This is third you need to identify. This is the fourth one, average turnaround time you need to identify. Next, fifth one is total turnaround time, TTT, total turnaround. It means when all the process its complete job. When all the process completed its job. It completed at 30th second. So under 30th second, all the process completes its job. Okay, this is the output. Are you clear? So next we will go to the exam, one more example. So this is the problem for you. You have to explain. You have to explain. Come, anyone? Venkatesh left. So come, I request anyone to initiate for solving the problem. You have 5 different problems. I no need to spend much time only on these problems. You have a lot of problems too. Okay. So I'm going to draw the Gantt chart. So this is the Gantt chart. So P1 is coming first. P1 is coming first. So what is the waiting time? 0. So when it completes, it completed by 5 seconds. It completed by 5 seconds. Next process, P2 is coming. Next process, P2 is coming. So P2 is executing. So P2 is executing for 3 seconds. That is a burst time. So 5 plus 3, 8. So P2 has come in the second order. So after completing P1 only, P2 can able to execute. So P2 is executing in the Gantt chart. 5 plus 3, 8. Then P3. So P3 is coming. You are enrolling P3. Now this is also burst time is 3. So until 3 seconds it will execute. So 8 plus 3, 11. Next is P4. So next process is P4 is coming. P4. So P4 is executing for 1 second. So 12. So the waiting time for P1 is 0. So this is the waiting time, and P2 is 5. P3 is 8. P4 is 11. So this is the waiting time for individual process. P1 is 0, P2 is 5, P3 is 8, P4 is 11. So before the process initiates, it's called as arrival time. Now you need to calculate the average waiting time. This is the waiting time. So this is the waiting time. So WT, this is the waiting time. Now you need to find average waiting time. AWT, average waiting time. So average waiting time is 0 plus 5 plus 8 plus 11. How many processes are there? Totally there are 4 processes. There are totally 4 processes, P1 to P4. So 5 plus 8, 13, 13 plus 11, 24. So 24 divided by 4. So average waiting time is 6. Average waiting time, AWT, average waiting time is 6. Okay. Now you need to find turnaround time. So TT, you need to find turnaround time TT. So TT is when the process completes its job. So P1, it completes by 5. So when P1 completes 5, P2 when it completes 8. When P3 completes 11. When P4 completes 12. So this is the turnaround time when it completes its work. Now you need to find average turnaround time, T average turnaround time. Average turnaround time is equal to 5. The process P1 completed plus process P2 completed plus 11 plus 12 divided by 4. That is the average turnaround time. So 5 plus 8, 13, 13 plus 11, 24, 24 plus 12, 26. 36. 36. So 36 divided by 4 equal to 9. So average turnaround time is 9. So after average turnaround time, you need to find total turnaround time, triple T, total turnaround time. So what is the total turnaround time? Total turnaround time is when all the process completes its job. When all the process completes its job is 12. So here only all the process come out from the CPU. Okay, at 12th second only all the process completes its job. So 12 is the answer for total turnaround time. So this one is the first waiting time. Second, this one is an average waiting time. Third one is a total waiting time. So this is the third one, turnaround time. This is the fourth one, average turnaround time. This is the fifth one, turnaround time. 5 things that you have identified by using this. Okay. Next. So next type of scheduling. First one is first come first serve scheduling, FCFS. Shortly we'll call as FCFS. Second type is shortest job first. Okay, shortest job first scheduling. Okay, why we need to go to shortest job first scheduling is there is some problem in a first come first serve scheduling that is called as a starvation. Okay, keep the word in mind, starvation. What is the starvation is? If the first process, it has 100 burst time. Consider there are 3 processes. We are discussing about first come first serve scheduling. First one, there are 3 processes. In 3 processes, the process 1 it has 100 burst time. It have 100 burst time. Process P2 have 1 burst time. Process P3 have 1 burst time. Okay, first come first serve schedule we are discussing. So consider when the process P1 comes, it will run 100 seconds in the CPU, but the process P2 and P3 it need to execute only 1 second because of having only 1 second. Because of it's having only 1 second, it need to wait for 100 seconds, which is executed by P1. So after 100 seconds only, P2 and P3 will be executed because it may comes with 0.1 milliseconds earlier when compared to P2. So what happens? The P2 and P3 wait for a longer time to complete the work, which is very less than when compared to current running process. So this is called as a starvation. Starvation means indefinitely it wait for a longer time, even the burst time is very less. Okay. So to overcome this problem, we are going to do shortest job first scheduling. So once the process is coming into ready queue, in a ready queue, so immediately what happens is whatever the shortest job that will execute the first, then the remaining process it will execute. So the system it will search for the length of the burst time. So the system it will search for the length of the next burst time. It checks the length of the process. Which one is shorter, that one it will be get running into the CPU. Okay, we'll see the example. Now there are 4 processes. So there are 4 processes which is there in a ready queue. Okay, P1, P2, P3, P4. Now what will happen is, as a shortest job for scheduling, it will always allocate shortest job to run in a CPU immediately. So what will happen? You need to draw a Gantt chart. So here it is checking which process having less burst time. So 3. So first one, it will allocate, P4. It will first allocate P4 to the CPU. So P4, 0th arrival second. In 3rd second, it completed. Then it will check which one is the less. P1 is less. Now P1 is allocated. So P1's waiting time is 3 because P4 is already executed. So P1's waiting time is 3. It is executing for 6 seconds. 3 plus 6, 9. Now among these two only balance, P2 and P3. So P3 is less. So P3 you are bringing into the CPU. So P3's waiting time is 9. It's running 7 seconds. So 9 plus 7, 16. This 9 plus 7, 16. Then P2 is running. P2 have only one process remaining. P2, it has 8 burst time. So already it waited 16 seconds. 16 plus 8, 24. Now all these processes are allocated to CPU by the manner of shortest job first scheduling. Okay, shortest job first scheduling. So which one is shorter, that will execute. It will execute in a CPU. Now we need to find the average waiting time. So average waiting time for P1 is average wait by having in the process order we are writing. Average waiting time for P1 is 3. Average waiting time for P2 is 16. Average waiting time for P3 is 9. Average waiting time for P4 is 0. So waiting time. So you are going to do average 3 plus, or you can do 0 plus 3 plus 6 plus 9. You can do 0 plus 3 plus 6 plus 16 you can do, or you can write in a process order. P1 is 3, P2 is 16, P3 is 9, and P4 is 0. 3 plus 16 plus 9 plus 0 divided by 4 is equal to 7. Then for this also you need to identify the average waiting time or turnaround time. So first turnaround time you are going to find. So turnaround time for P1 is, when P1 completed 9, P1 is 9 plus or 9, P1 is 9. P2 is, when P2 completed 24. When P3 completed 16. When P4 completed 3. So this is the turnaround time. This is the turnaround time. P1 is completed at 9. P2 is completed at 24. P3 is completed at 16. P4 is completed at 3. So this is the P4. So you're going to add this and divided by 4. Okay. So 30, 40, 52. 52 divided by 4. 52 divided by 4. 1, 3. So 13 is the average turnaround time. 13 is the average turnaround time. Turnaround time is 13. Okay. So total turnaround time, total turnaround time is 24. At 24 second, it has completed its job. This is the shortest job first scheduling. So now it's your time. You are going to solve this problem. Okay. So I'm drawing a Gantt chart. So 4 process. 1, 2, 3, 4 process. So anyone come forward and tell me which process it will execute first. Anyone unmute and let me know which process comes first.
P3, sir.
Very good. So P3 comes first. So P3's arrival time is 0 because it is executing first. So when it has completed, it completed at 10th second. Next, which process? This is over. Next one.
P4, sir.
P4, sir.
Next process is P4. So next is P4. So P4 is executing for 15 seconds. So 10 plus 15, 25. So this is also over. Next, you have two processes. So among this, P1 is less. So P1 will execute it. So it has 20 burst time. 25 plus 20, it is 45. Then you have only one process, that is P2. So P2 is only process 45 plus 25, 50, 70, right? 50, 60, 70. Yeah, no, 70, correct. So this is the this is the Gantt chart you are going to find. So waiting time for P3 is 0. Waiting time is P3 is 0. P4 is 10. And P1 is 25. P2 is 45. So this is the waiting time of individual process. So P1 is 25, P2 is 45, P3 is 0, P4 is 10. So this is the waiting time. So WT waiting time. You need to find average waiting time. So what you are doing, 25 plus 45 plus 0 plus 10. 70, 80. 80 divided by totally 4 process. 50, 60, 70, 80. So totally you have 4 process. So 80 divided by 4. So 20. So 20 is the average waiting time is 20. Average waiting time is 20. Okay. Then you need to calculate turnaround time, TT. You need to calculate turnaround time. So turnaround time for P1 is, P1 when completes its job, it completes at 45. P1 is 45. P2 when completed, P2 completed at 70. P3 completed at 10. P4 completed at 25. So you are going to add this and you are going to find average turnaround time. Okay. 80, 80, 80, 40, 125, 130, 140, 150. So you 150. Yeah. Total is 150. So 150 divided by 4. That is average turnaround time. Okay, it will comes around some 130, 120, 30, 38 point something. Okay, so this is 3, 30, there is 28, 7, 37 point something. So 37 point some 45 something or something you will get 37.45. So that is the average turnaround time. So total turnaround time, triple T is 70. So when all the process completed job is, it completed by 70. Okay, this is the total turnaround time. Okay. So I think you are clear with shortest job first. You need to execute whichever the shortest, that only you need to execute first. Okay. Shall I go for next, the third one? Okay, right. Next. So this is the way how it will predict the next CPU burst time. So whenever the process is in a ready queue, it will predict what are the next process that is available in a CPU. So it will get identified. Based upon that, it will be executed. So this graph and all you will be thorough when you completed the scheduling methods. Okay, this is the third one, priority scheduling. Third one is a priority scheduling. So why the problem that we are going to priority scheduling? As I said, starvation. You have a starvation in the first come first serve scheduling, because very less process it wait for a longer time. Okay, and then aging, as time progress increases the priority. So for example, if the process is coming in a ready queue, if any process it requires higher priority, any process it requires some higher priority, so you need to stop the current running process and you can allocate. So what you will be giving is, when it comes in a single time, first run the priority, which one having higher priority, give the preference for higher priority, then you go with the other priorities. So you will be giving the priority with the scheduling. So we'll see an example, you will get a clear more idea about it. So priority and number is associated with each other. So the smallest integer is the highest priority. If there is a 1 is the highest priority, then 2, then 3, then 4. 5 is less priority when compared to 1, or 5 is less priority when compared to 4, 3, 2, 1. Okay, 1 is the higher priority, 2 is the next. So the levels is, first is the higher, second, 3, 4. So first is always higher priority, 4 is a lower priority in this. Okay, so it is an example. So you forget about this part. Okay, arrival time is 0. So there are 4 processes, P1, P2, P3. Burst time or duration is 6, 8, 7. Now for this problem, you will be provided with the priority. You will be provided with the priority. So priority is 4, 1, 3, 2. So here the priority for the process is given. Among this priority, P1, it gives first priority for execution, because even though the burst time of P3, P4 is less, it works based upon the priority that what you are giving with your process. Okay, first what will happen? The process P1 have higher, P2 have higher priority. So what will happen? CPU allocated to the P2, 0 arrival time. P2 is allocated. P2's burst time is 8. P2's burst time is 8. So 0 plus 8. So P2 is completed. Now the second priority is for P4. Now P4 will be executed in the CPU. So its burst time, it completed 8. So at 8 second only P4 it allowed. P4 burst second is 3. So 8 plus 3, 11. So now this is also over. Next priority is P3. So what will happen? Now P3 it will be start executing. P3 it will be start executing. So P3 it will be start executing. P3's burst time is 7. So 11 plus 7, 18. Next last is P1. P1 it has 4th priority, which is last. So it will execute at the last. So 18 plus 4, 18 plus 6, it is 24. So this is the way the priority scheduling it works. It will work based upon the priority given to the process. So now we need to calculate the waiting time. So what is the waiting time for P1? P1, everything it came under 0th second only. P1's waiting time is 18. P2's waiting time is 0. P3's waiting time is 11. P4's waiting time is 8. So this is the waiting time. All it came in a ready queue, but because of priority, P2 executed first, then P4 executed second, P3 executed third, P1 executed fourth. So the waiting time for P2 is here 0. This is 8. For P3 it is 11. P1 is 18. So this is the waiting time. You need to calculate average waiting time. Average waiting time is 0 plus 8 plus 11 plus 18 divided by 2, 9.25 is the average waiting time. So then you need to identify the turnaround time. Then you need to identify the turnaround time. Hello. So 0 plus the turnaround time is like P1's turnaround time is 18, P2's turnaround time is 8, P3's turnaround time is 11, P4's turnaround time is P4's turnaround time is, where is the P4? Sorry, P3's turnaround time is 18. Yes. P4's turnaround time is 11. Sorry. So P1's turnaround time is, I did mistake some, wait. So we'll erase all things, right, sorry. So now P1's turnaround time is 24, sorry. P2's turnaround time is 8. P3's turnaround time is 18. When it's completed, P3 completed at 18, P1 is completed at 24, P2 is 8, P4 is 11. So P4 is 11. This is the turnaround time. You need to identify average turnaround time. What is the average turnaround time? You are going to add it. 24 plus 8 plus 18 plus 11 divided by 4. So that is your average turnaround time. Sorry. Next is you are going to find the total turnaround time. So triple T, you are going to find total turnaround time is 24 or 24th second. All the process, it's complete job. So average turnaround time, you need to find the total 24 plus 8 plus 18 plus 11 divided by 4. That is the result. So this is the priority queue. So which one you need to execute is? Which one you need to execute is based upon the priority only you are executing. Okay. Next. So anyone? So there are 5 processes. So I'm drawing process 1 process, 2 process. 3, 4, and 5. So this is the process. So which process will executed? Anyone?
P2, sir.
Which process it will execute first? So this is the 0th arrival time. Which one will execute first?
P2.
P2, sir.
P2. Very good. P2 will execute because P2 have a highest priority. So it will execute only 1 second. The burst time is 1. So now this is over. Now what is the second priority? Second priority is P5. So P5 is the second priority. It has a burst time of 5. So 1 plus 5. 6. Now this is also over. Next, third priority is P1. P1 is having 10 burst time. So P1 is having 10 burst time. So 6 plus 10, 16. This is also over. Next, fourth priority is that we are having P3. So its burst time is 2. Its burst time is P3 process. So this is P1 is running. This is P3. So P3 is having fourth priority. P3 is having fourth priority. So it having burst time as a 2. So 16 plus 2 is 18. Then last process is P4. P4 is having only one burst time. So 19. Some mouse problem. So 19 is the. So you need to calculate the average waiting time. So P1's waiting time is 6. P1's waiting time is 6. P1's waiting time is 6. P2's waiting time is 0. P3's waiting time is 16. P4's is 18. P5 is 1. So you will be adding that and divided by 5 because 5 process. That is called average waiting time and waiting time. Waiting time for P1 is 6. P2 is 0. P3 is 16. And P4 is 18. Okay, P5 is 1. So this is the waiting time. If you are adding and divided by 5, that is the average waiting time. Turnaround time is when the process completes its work. So P1 completed by 16. P2 completed its work by 2. P3 completed its work by 18. P4 completed by 19. P5 completed by 6. P5 is completed by 6. 6, yes, it completed by 6. So this is the turnaround time. If you are adding and divided by 5 means that is average turnaround time. 16 plus 2 plus 18 plus 19 plus 6 divided by 5 is called average turnaround time. So total turnaround time is triple T. Triple T is 19. That is when all the process completes its work is 19. Okay. So it is another example for this is the output. Okay, this is the output. You can see 0, same P2, P5, P1, P2, P5, P1, P3, P4. Okay, same 0, 1, 6, 16, 18, 19. 0, 1, 6, 16, 18, 19. So P1's 0 plus 1 plus 6 plus 6 plus 18 divided by 5 is equal to 8.2. This is the average waiting time. Okay. So next you are having round robin that we will discuss in next class. Don't leave the session. So 3 things that we are completed today. One is first come first serve scheduling, shortest job first scheduling, and then priority scheduling. 3 schedulings we have completed. So still 3 more schedulings are there. One is round robin method. Then you have multi-level feedback queue. Multi-level queue. One more is multi-level feedback. So totally still 3 more problems are there. I'm repeating round robin. That is the 4th one. Multi-level queue. This is the 5th one. Multi-level feedback queue. This is 6th one. So here in multi-level queue, you don't have any problems on it, but you need to understand. But here multi-level feedback, you have problems. Okay, so you have problems. So among 6, only the multi-level you don't have a problem. Sometimes they may ask. I will tell you if they're asking problem how you can do. Okay.